Today we're looking at 6C.3. I can solve for the missing side of a triangle by applying the side splitter theorem. Okay, so we're talking about this thing called the side splitter theorem. So the side splitter theorem says if a line is parallel, you're looking at parallel lines again. Likes to jump. The line, stay. If the line is parallel to one side of a triangle, so if you look here, right, I have this line and this line are parallel. That this line divides the other two sides. The other two sides proportionally. So divide the other two sides proportionally. So what we mean by that is QR, so the top part of the triangle on the left, over the bottom part of the triangle on the left, is going to be the same as the top over the bottom. And we'll look at lots of examples. But if you notice, QR and QS are both on top, RX and SY are both on bottom of that line that cuts the triangle. So let's look at some examples. Again, I always like starting with the variable. We're going to start with X over, right, so top over bottom, 3.2 on the same side. They're both on the right side. And that has to equal, again, top over bottom, 3 over 2, the left side. Now, it's just like what we were doing before. I'm just going to solve by using my cross multiplication. So I have x times 2 equals 3.2 times 3. That's 2x equals 3.2 times 3 is 9.6. Divide both sides by 2 because there's multiplication here. I get x equals 4.8. Alright, looking at my next example, example 2. Again, I like starting with the variable, so I'm going to do x over, and this triangle has been rotated, but 6 is on the same side as x. Equals 3 and 4. I'll be honest, I always start with the variable. It doesn't so much matter how you set them up, as long as you're going back to the same side that you started with. Okay, so just be careful that you're always going kind of back to the same place you started. Now again, cross multiplication. So I have x times 4 equals 6 times 3. 4x equals 6 times 3 is 18. Divide both sides by 4. 18 divided by 4 gives me 9/2, or if you're using a calculator, that's 4.5. Okay, so either one. I do not care if it's a fraction or a decimal. Alright, example 3. Okay. I'm solving for y. Now, this gets a little bit different. I would just like to set up y over 4, but if you look, oh no, I don't have anything on the other side. So for this one, I have to use my triangles. I have to use the red triangle and then the blue triangle. Okay? So I'm going to do red over blue, red over blue. Okay? So that's y, starting with my variable, over, well, for my blue triangle, I have this and this. It's not just 4. If you look, it's y and 4. So I have to put those together. Going back to my red triangle, all right, 5 over, in my blue triangle is 20. So sometimes these ones get tricky. So be careful there. Now that I have this, I'm just going to do my cross multiplication, making sure, again, there's a plus sign, so I have to put those parentheses. So I have y times 20 equals y plus 4 times 5. So that's 20y equals 5y plus 20. I need to get all of my variables onto one side, so I'm going to subtract by 5y. So 15y equals 20. Divide both sides by 15. 20 over 15 is 4 over 3. All right, our last example, example 3. Use the side-splitter theorem to solve for all variables. Okay. So I'm going to start with h. And I'm going to look ahead. Can I do h? Right, top over, ooh, bottom, I don't know the bottom there. Okay, so again, I'm going to be looking at the whole triangle. My red triangle. My blue triangle. Okay. So, in my red triangle, I have h over. In my blue triangle, I have 33. And that has to equal, in my red triangle, the other thing I have on this side is 15 over, in my blue triangle, again, it's this whole side, 15 plus 30, which is 45. Okay, so 15, my blue side is 45. Make sure you're adding those together. Then again, it's just cross multiplication. I have h times 45 equals 33 times 15. So 45h equals 33 times 15 is 495. Okay. And use a calculator to kind of make it go faster. And then I'm going to divide both sides by 45. Right, those cancel out. H equals 495 divided by 45, we get 11. I'm going to put that in my picture. Alright, the next thing I'm going to solve for, let's solve for k. Why not? So, to solve for k, right, now if you look, I can use the side-splitter theorem here. Okay, so I'm going to start with my variable k. Over, well, where h was, we now know it's 11 here. So k over 11 is going to equal, on the other side, I have 30 over, right, up here we have 15. That's a 5. Okay, so now this one I am using the side-splitter theorem. So we're kind of combining our similar triangles, what we did in C1, C2, all of that, with this. Now, cross multiplication, that's k times 15 equals 11 times 30. 15k equals 330. 330, not 333. Divide both sides by 15. K equals, we get 22. Okay, our last one for P. again, I'm going to start with the variable p over, I can't use my side splitter because this side isn't being split by that. So I'm just going to do red, blue over red, so p over 12. And then I could use any of the sides. I know everything else, so I could use any other side. I could use this, or I could use this. Let's use this side. Why not? So I have 45 over my red triangle is 15. Again, now I'm just doing some cross multiplication. P times 15 equals 12 times 45. 15p equals 12 times 45 is 540. I'm going to divide both sides. Slam something. By 15. I'm going to simply move it up so that I can write. Right, those cross out, so P equals 540 divided by 15 is 36. All right, there's a few more examples that we're going to look at on the other side that are very similar to these. Okay. Here we are looking to the corollary to the side splitter theorem. So it's very similar. Right, corollary is just something that's very similar to the last theorem. That's all it really means. So, corollary to the side splitter theorem is when three or more parallel lines are intersected or crossed, right? Think about an intersection in a road. Intersected by two other lines. So if you look, I have my three parallel lines here, and these two lines are crossing all three of them. Then we say then the segments are proportional. So again, all I mean by that is I have, right, it's the same type of thing. AB over BC is equal to WX over XY. So the only difference here is I don't have a triangle. I just have three parallel lines. But it gives you, it's the same exact thing. Okay? So let's look at example 4. All four of these lines are parallel. A, parallel to B, parallel to C, parallel to D. Okay, and some of the lengths are written in, and then it says KP is 24. So K all the way to P is 24. Find KM. So KM is so I'm going to do X over, it gives me, right, this whole side between from A to D. Okay, so 24 is A to D. Then on the other side, right, X was only A to B, so A to B is 5. Over, I have to do the whole side A to D, which is 5 plus 2 plus 8, right? I have all three of these, which equals 15. Okay. So X over 24 is one of them, 5 over 15 is the other, adding all those up. Cross multiply, X times 15 equals 24 times 5. 15x equals 24 times 5 will give you 120. Divide both sides by 15. X equals 120 divided by 15 is 8. Okay. That was weird. Just do that a little bit. All right, our next one. Now, all of these lines are parallel. Okay. FG equals 2. GH equals 8, H to J equals 5, E to M equals 6. The first thing I want to find is EO. I'm going to put just an X there. That's my variable. So I have X over 6, right, this side over the longer part of this side, equals. Now, X was between these two lines, between those two lines on my other side is 2. 6 was between these two on the other side is 2 plus 8, which is 10. So X over 6 equals 2 over 10. That whole distance. Gotta cross multiply. X times 10 equals 6 times 2. 10x equals 12. Divide both sides by 10. 12 divided by 10 is 6/5. Alright, the next thing I'm finding is EK. Last thing. EK is from here all the way to here. I'm going to call that Y. So I can do Y over, on this same side I have a 6. Then Y was between this line and this line. I have to go all the way across. I have 2 plus 8 plus 5. Alright, 2 plus 8 plus, that is a 5, is 15. And then 6, again, was between these two lines, and it's 10 again. Okay. Now that I have that set up, I'm going to cross multiply. Y times 10 equals 6 times 15. 10y equals 6 times 15 is 90. I'm going to divide both sides by 10. So y equals 90 divided by 10 is 9. Alright, this one was a little longer, but go ahead and work on C3.